Okay, so every time I'm multiplying by 4/3. Okay, so I go from 1 to 2, I multiply by 4/3, go from 2 to 3, I multiply by 4/3, go from 3 to 4, I multiply by 4/3. So Pn, the nth perimeter, is the first perimeter times 4/3. Now this is a challenge. What power do I have to multiply 4/3? 4/3 times what? If I want to get to the nth perimeter down here, how many times do I have to multiply it by 4/3 starting from P1?
Pn minus 1.
Okay. What do you think?
You have to multiply it by n minus 1.
Okay. Well, not multiply by n minus 1, by n minus 1 4/3. Yeah. So to go from P1 to P2, I need to multiply by 4/3 once. Actually, go from P1 to P1, how many times do I have to multiply by 4/3?
No times.
No times. No multiples by 4/3. 4/3 is the 0 power. If I want to go to the fourth one down, I multiply by 4/3
times
to the third power. And if I want to go to the 100th one down, I'm going to multiply by 4/3 to the
99th.
to the 99th. And so now I want to ask you a question. Why does Pn go to infinity? And by that I mean get larger and larger and larger and larger.
Well, because you're multiplying these 4/3 together and they're larger than 1. So every time you multiply, it gets larger, 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 until it'll go to infinity if you do it infinity times.
So you have 3 options for infinite multiplication. So you can either have something less than 1, multiply it and the number by something less than 1 infinite times. It'll converge to 0.
Okay, well, let's be careful. You mean a positive number that's less than 1.
A positive number less than 1.
Yeah, okay.
And if you can multiply a positive number by, or actually any number, by 1, and it'll just stay as it is.
Okay.
Or you can multiply by something greater than 1, and it'll go up to infinity.
Okay.
Then we're multiplying something greater than 1.
So infinity seems right.
Alright, so we have something interesting with the perimeter happening here. So we get a geometric, what's called a geometric series, where we're just always multiplying by the same amount to go from one perimeter to the next all the way up the chain. And that tells us that the perimeter is getting large. And to be just even slightly more precise mathematically, when I say it goes to infinity,
Yeah.
what I mean by that is by saying any number I pick, no matter what number it is, I pick 100, or I pick 1,000,000, or 1,000,000,000, or Graham's number, I'm always going to be able to find some level where the perimeter is larger than that number.
Yeah. Graham's number plus 1.
Well, it depends how many times I multiply by 4/3, but I'll be able to find, this always just gets larger and larger and larger and larger.
Yeah.
And so now we have demonstrated that the perimeter of the Koch snowflake is what?
Infinity.
Infinity. So the last question, do you believe it?
Yes, now that we've kind of proved it.
Well, but some things we've proven and you don't believe them, which is fine.
Yeah.
But do you believe this? Do you believe the perimeter of the Koch snowflake gets larger every time?
Yes.
Okay.
Then that means it'll go to infinity.
All right. So, okay, so good. So now we've solved half of your puzzle.
Yeah.
Tomorrow we'll take a look at the area and see what happens.
Okay.
And the area is a little bit different because instead of being multiplicative like this, the area you're adding on new pieces every time. So
Yeah.
the area looks a little bit more like that 1 plus a half plus a fourth plus an eighth thing.
So, because you're adding on.
You're adding on pieces every
Well,
time.
but you're adding on. It seems like the same argument because you're adding on smaller pieces, but you have lots of them.
But it's area.
You're
not
right.
Lines.
Well, We'll see. We'll see tomorrow. But you're absolutely right. It does seem like the same thing. Like you're adding on these extra pieces, and they get smaller, but you have lots of them. So maybe it also goes to infinity.
Cool.
Or maybe it's more like the 1 plus a half plus a fourth plus an eighth.
Thing.
Yeah. All right.
Really cool.
Good work, guys.